Hello everyone, today we will discuss how to connect encoder to the Mitsubishi PLC FX3U. This is our manual. If you want to more details, you can download this manual for the using encoder. Also here's more description. This is also the number of manual. This one is the number of manual. You can check, and also this is a part of high-speed counter in this page, and so here okay, here we have also there is more detail about the encoder, how to connect, and there is three type of the connection with the encoder. Here is written about that one. First is one phase and one counter input, second is one phase and two counter input, and third one is two phase and two counter input. Now first we will check which encoder we will connect to our PLC and how is the parameter of the encoder. Now we will see that one. Just I want to make video. This one is my encoder. Here you can check. This is Omron. The model is ECB2. So this is a 5-wire encoder, and resolution is 360 per revolution. So also power supply is 5 to 24 volt DC, and is written also blue is brown. This is a power positive, and blue is common. So there, so the shield is ground, and here you can also check the black wire. This is output A, and white is output B, and orange is output Z. So here also what I have here, this is my Mitsubishi PLC CPU, and wiring also already I make. So you need just power supply to encoder, and sequential I'm connecting A wire to X0, and B wire to X1, and Z to X2. So combination of my wiring from the encoder here already connect, and we will check how the programming we can do with encoder. Okay, first about the theory, we can just check the manual. Now we have the high-speed counter here. This is a kind of the high-speed counter, and this is a table. This table is important. So if you want to use one phase one counter input, you need to use this counter. So from the C 235, and also if you want to use two phase counter, you need to use this counter C 251. This is the counter, so the high speed counter already in the PLC. There is also another detail, the table. For example, if I am using one phase counter, what is the difference between one phase and two phase? So if in any counter we have 3 wire output, if that one is 5 wire, if that one is 3 wire encoder, so this is means 2 wires is power supply, and one wire, this is the A phase. So one phase we have. If this one is 5 wire encoder, this means you have a 2 wire power supply. You have A phase, B phase, and Z phase. So in one phase you just need one wire of the encoder. For example, I am using A phase. This one for this table for the one wire. If you are using the counter of C235, so X0, this is your counter in phase A. And also there is some memory to the counting and for the resetting, opposite counting and resetting in one phase counting also inputs. In one phase you just can do incremental calculation or counting or decremental of the calculation about the position or about the encoder. But in two phase you can both you can use incremental and decremental together, because you can also, if you are using encoder in the position control, you can also check the absolute position control. But for example in A phase you just incremental. We have also like this encoder. So here this is this table, for example, how you can understand what is this one. For example, x0, if you using this counter, this means x0 for the up and down counting. But for the up and down counting also you need to set one memory. We will say after what is this memories. If you want to use the x01, you need to use this counter. So this is the clear. But in 2-wire you just check in 2-wire. If you want to use the counter of C 251, A this is X, this A this is X0, and B is X01. So these two, just we need 2-wire in two-phase counter. But if you want to reset, you can just do some memory here in X02. You can also do resetting, but you need to use this kind of the counting. So this is about the inputs. So here this is a detail about the using the counter. This is a single one phase counting, and also some details I want first we will discuss after. We will completely go to this programming, and there we will discuss. We have like this 4 of the instruction we have here. This means high speed counter set, and high speed counter reset, and high speed zone, and high speed this one high speed counter. This when using this count high speed zone compare or high speed count instruction using maximum response frequency, total frequency of the software counter are affected. Okay, this is no problem. Just this you need this instruction just you can use in only one time. And this one is memory. What I say about the memory, if you want to use opposite calculation, for example minus calculation, you just need to which counter you are using, but you need this, for example, that memory for the opposition of the counting. Oh, here also I want to show you one was good things here. This is the frequency of the counters. Operation, just this one. This is also important. Never use the high speed inputs. For example, they use using x0 for the counter input enabling. So never don't use this one. For example, I'm also using this memory. Always is run when the CPU is running, because when you're using this this high speed counter input, you are counting, and also your encoder will be values will be very bad. You cannot calculate clearly. About the one phase counting and up down. Okay, here is detail about this one. For example, if you are using one phase, if you want to up, need this memory need to from this memory starting need to off. If you on this one, you can check, you can calculate down. Okay, here was another details. I just want this details. I just want to this one. This instruction you can just only using in six times, so there is limitation for this instruction when you are using this instruction. Okay, this was about the theory of the counting, high speed counting. Now I'm using M80030 for the always is counting. You don't need any input, for example x0 or x1 or some another input to the calculate. This one is calculating automatically. Just I want to reset here, so I'm resetting all counter. The first counter about just wait, I want to show you one table. Was here this table, you can check x0. This is a counter of C235, x1 is 236, and x2 this counter. Okay, I am here also 5 counter I connecting already. Just I want to calculate in our counter. This means the first counter, this is a phase A, and second counter, this is a phase B, and third one is phase Z. When I am rotating counter, for example in clockwise, you can check now calculating phase Z. This one is encoder. When the encoder revolution is completely one cycle, one revolution is counting 1. So this is the revolution of the counter. So for example, if this one is 5, this means my counter 5 time is revoluting. So one from my technical parameter of the encoder, I need 360 pulse in one revolution. You can see also my counter, this revolution counter is calculating 1. Okay, when I'm opposite, also when I'm rotating, there is no affecting here because I'm using one phase for the calculation. Now what I want to do, I want just phase A, I want to calculate opposite, so minus. I need to just on this memory. I will on this memory. You can just check my phase A, so this means x0 is calculating opposite. If any rotation I'm doing, so clockwise or anti-clockwise, this one is going down. You can check here, coming to 0. This is the memory for the opposite side of the counting. Now you can check that he is becoming minus. For example, I will if I want to do in my second counter, my second phase B, I need to on just this memory. You can also check phase B also coming down to 0 and minus. Also, if I want to phase, this is phase Z, and this one is connecting to the x002. I make on, and you can check is going down, so near to 0. So just one off this memory and off all this memory, and I will reset. On and reset. Okay. Now you can check. I am using this normal open contact from the C 235. So this means here, if it's coming to 5 rotation, so my output will be on. Now you can check here. I will rotate 1, 3 and 5. You can here see my output is on. So when you're using the normal open contacts, so clear you can do this one. Also there is another instruction. What I say about this one was a limitation instruction we have there. High speed, this instruction, high speed counter set and high speed counter reset. For example, LD-Kun, for example, M100, high speed counter set. What was the instruction? HSCS. And C236, for example, K 1000. Just, and the output is 110. There is some mistake here. Just you need to use 32 bits, so just you need the high speed counter set. Okay, first what we need to do, see 236 when K1000, for example, and output from us is Y10, for example. Okay. Again some mistake here. Sorry about the mistake of the instruction. Just I check here. We need to first need to put the pulse, how many pulse, and after we need to use the counter, and third one is output. Okay, in 1000 my output Y10 is becoming on, and also I can do like this one, and DHSCR reset kun K 115 C2 236 and Y 010. Okay, we will make view, then right close. And close. Now it's off. First we need to reset. Okay, now I will rotate my encoder. Sorry, here again, on and off. Now need to on this memory. Okay, now I will rotate, and now my output is on. When I'm continuing, my output is off. Okay, this is using this instruction. You can also use the LD instruction, LD equal or LD big more than this value. You can do this instruction, no problem about this. But there is also a high-speed compare instruction. You can also use that one. Just what we need here, just about the counter wiring and how we can use. This was the one phase counter. Now we will do another one. This is another program about the two-phase counter. What we say about the two-phase counter, this one is two-phase. Now I am using counter C251. A, this one is X0 and B is X01. Okay, now we will check how it's working. Now we will go to online. Now it's 0. Okay, I am rotating my encoder here. Now it's resetting. Oh, why is resetting? Not working. Why is not working? Because which one I'm using here? If we need this one, counter. Okay, sorry, now I'm using this one. This is another one. Now in here we are using counter C251. Okay, now I have some rotation in clockwise. So this memory is off. I'm making on. By rotating to clockwise, you can check here how is increasing. If I rotate opposite side, so you can see here is decreasing automatically. This is kind of using the encoder. This is a two-phase encoder. You can in two-phase you can control absolute position, because your encoder, if rotating in clockwise, for example, this one is increasing. If you rotate to opposite and anti-clockwise, this one is decreasing. So you have also completely absolute controlling. For example, if you are using in position control, your motor is going to some place, going to some area. After what you want to come back to there, so you can use this kind of the encoder to come back to the base and to the first place from where your motor is rotating. This is the absolute controlling here. In the manual also we have another counter. For example, if I want in one rotation reset my encoder, so I'm using the counter of the counter C215 too, because my Z wire is connecting X002. In one rotation my counting is resetting and becoming 0. So this was about the encoder and how to connect the encoder to Mitsubishi PLC. Also there is more detail here what I'm done here. I want to discuss with you, and thank you for watching.